Hi, we're the Extraordinary Team, and this is the Smart Bookshelf.
Hi, my name's David Bruan.
Hi, my name's Tran.
Hi, my name is Figueroa Garcia.
I'm Charles Kelzer.
Bookshelves are commonplace and seem to be without issue. However, they lack a certain type of flexibility, accessibility. By accessibility, we mean that the fixed height of bookshelves can be an inconvenience to people who struggle reaching for items on a bookshelf. The motivation behind our project was to improve the accessibility aspect of modern bookshelves. In order to solve this issue, our goal was to design a mechanical bookshelf whose shelves can be raised or lowered at the convenience of the user. In order to make this idea possible, we decided to implement a lead screw linear actuator device into our mechanical bookshelf to aid in creating a bookshelf accessible for all. Our product was designed for people who are casual readers and educators who may need our book storage. The main objective of our product is to design a bookshelf that is accessible. Other ideas that our design should consider including is for the bookshelf to be lightweight, affordable, be structurally safe. It should be space efficient and should have a decent storage capacity. Additionally, it should be safe for operation and have a nice raising and lowering speed of the shelves. Through implementation of a lead screw mechanism, our bookshelf should be able to resolve the main objective. Additional features to include are bookends to hold the books in place and removable shelves and lightweight material.
And here's a quick overview of the final design. The system has a total height of about 4 feet with the shelf length up to 36 inches. It will have the capability to carry up to 25 to 30 books per shelf. And it's designed to ideally mount it on the wall from 5 to 6 feet above the ground. We will allow the sufficient space to set up the entire working station underneath. And more importantly, the total distance that the lead screw mechanism allow the shelf to travel is up to 3.5 feet from its lower limit to the upper limit. Next slide, please. Some of the major components include the lead screw shaft, the linear ball bearing on two sides of the rail to allow the smooth linear motion, the lead screw nut for the moving mechanism, the shaft coupling, as well as the ball bearing to reduce the friction, and the stepper motor. Next slide, please. And we would like to present the working concept of the final design. As you can see right here, the clockwise location will allow the shell to raise up, and on the different on the opposite direction, we'll lower it. And we are attempting to use the book game to hold the book upright. Okay.
For our bearing analysis, the weight was divided in half to account for the two sides of the lead screws. Our first analysis gave us a value of under 100 hours, which didn't seem correct. But then fixing a problem which was caused by using the wrong units, we obtained a value of 10 million hours, which seemed more acceptable. And we concluded from this that our bearing in this assembly would be sustainable because it's made of steel and it's only axially loaded with 70 foot-pounds.
For the lead screw analysis, it's important that we understand the dimensions of the threads. The diagram below is of an Acme threaded lead screw characterized by its slanted teeth. The important dimensions are the major diameter, pitch diameter, and thread angle. Next slide, please. Next, we need to understand the free body diagram of the lead screw. Here, the contact point is represented by the orange box, and the triangle is the angle of the thread. We are able to extract parameters such as the friction, the load, and the distance per turn with this free body diagram. With that, we were able to calculate the torque needed to lift the shelf up, which would be 46.447 pound-inches, and to lower it down would be 35.17 pound-inches. Next slide, please. For the shelf analysis, we treated it as a beam by isolating one shelf, fixing the holes where the lead screw and the guide rails go, and applying a 30-pound load to mimic the weight of the books. At 150 psi max von Mises stress, the stress on the shelf is far below the yield strength.
In conclusion, we found that the bearings were not at high risk for failure. We found that the stepper motors were only being used at a quarter of their capacity to lift the entire load, and overall that our shelf, as we designed it in CAD, was sustainable for everyday use. These are our references, our bill of materials, and our exploded view.
And here's the real-life ideal application for a smart bookshelf. This extraordinary team. Thank you for listening.